History. Today I discuss about arithmetic progression, very important for CBSE class 11 12 students, and for others who is studying in mathematics. So very important and interesting topic. So before starting, I must appeal to all of you to subscribe this channel. Go and subscribe the videos. Subscribe. If you like, then like, and if you like, then comment me. If you have any suggestion, you can also comment me. Subscribe this channel. So let's start now. First, we know what is sequence. If you know the set, behavior of set, then you can very easily understand. Actually, sequence is a mapping, and giving the operation is from n to r. Means n is the set of natural numbers. Set of natural numbers. Set of natural numbers. R is the set of real numbers. So you can very easily understand there is a mapping. Mapping must have a definite rule, otherwise it cannot be a mapping. So there is a mapping from natural numbers to real numbers. I am giving an example, like you take this operation. It is the sequence denoted by in this symbol. I am giving n by n plus 1. So all n where all n belongs to each set of natural numbers. If we put the natural numbers, then we'll get the full sequence. So how we can obtain a sequence? If we put first 1, then we will get 1 by 2, then we will get 2 by 3, then we will get 3 by 4. So all belong to real numbers. All belong to real numbers. So there any mapping or any operation or any function of from natural numbers to real numbers is called a mapping. We a sequence, and there must have a definite rule. Mapping must contain a different rule. So sequence have a different rule. So this is the definition of a sequence, and there is a example I have already given. So we also know what is series. Series is actually series typically given by the summation of the sequence from any finite number n is equal to any finite or infinite number n is equal to 1 to infinity, and the sequence is so the summation works as an operation on the sequence, and whatever the result will be, there will be series can be obtained in this way. The series will be in this way. First, if you put 1, then this will be 1, is 1. Yes, if you will take 2, then there will be S1 plus S2. In this way, a series can be obtained. S1 plus S2, or it can be that we can take 3. There will be S1, S2 plus S2 plus S3, and in this way it will continues. So in this way it continues, and last element will be S1 plus S2 plus S3 plus dot 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 S. So n can be finite or infinite. This is the uh, presentation of a series. I hope you can understand. So now we will know the progression. To study the arithmetic progression, we will study the progression. Progression is a one kind of sequence, a increasing or decreasing sequence, increasing or decreasing sequence can be the value after one value increase or decrease or increasing or decreasing sequence is a progression. Called a progression, but you have to remember at the same time that any member can be obtained by another member, called is progression if any member, if any element or any member can be obtained by another element or another member. Any member can be obtained by another member. So there must be a certain rule, otherwise you cannot obtain a member from another member. There must be a certain rule in progression can be obtained from another member. So we first study there are three type of progressions: arithmetic progression, geometric progression, and arithmetic progression. Arithmetic progression and geometric progression are very hugely used. So we first study arithmetic progression. And later we will study the geometric progression. So here it can be progression, so it may be increasing or decreasing. Also, and each member each member with the previous member, you can take A1, A2, A3 as arithmetic progression members. A3. So all the members must be related with the another member with a common difference. All the members will have a common difference. If you will subtract A2 minus A1, you will get the same element as you will subtract A3 minus A2, you will get same element. You will have a common difference between any two element. If you take the one after one, A2 minus A3, if you take a common difference D, then A2 minus A1 will have a common difference D. Then any member, if you take A, R and ER plus 1 in this member, so they also have the same common difference D. So it can be a plus D or minus D. It can the series, if it is increasing series, then always the next term will add up plus D, and if it is the decreasing sequence progression, then the next term always add up minus D to the next term. So in this way arithmetic progression are arranged. So you can very easily now write down the first member. If you write A, then the second member will be A plus D or A minus D, plus minus D. If you take plus, then all the you will have to take plus. And if you take minus, then all you will have to take minus. A plus minus 2B. You can look this here. The difference between these two members is just D, and here also difference is just D. So this is the quality of this progression. And the last member, if there are n number of elements, then the last member will be plus minus. You will look this. The second term here is 1. The third term there is 2. So the nth term here will be n minus 1. N minus 1 D. So this is a arithmetic progression. I am giving an example of arithmetic progression. Like if you are taking 5 first element, uh, uh, 5 first element, and we are taking first element, we are taking 5. This is denoted by A. So A is taking 5, and the common difference we are taking common difference is denoted by D. We are taking D is equal to 3, and this is increasing procession sequence. So the next time you can very easily understand this will be 8, and the third term will be 11, and another term will be 14, and so on. So if we wish to know the nth term, uh, we if we wish to know the nth term can be given by relation. Nth term n will be first term a plus n minus 1. If we know wish to know the 15th term of this progression, arithmetic progression, how will you calculate? A50 we will put here, and at the first element we have taken 5, and n minus 1 will be 49, and d we have taken 3. So if we calculate it, it will be 147, 5 plus 147. So this will be the 15th term of the progression. This will be 152. And if we wish to know the series, so here if this is the sequence. If we wish to know the series, S1 is just A. This will be 5. It is important to know the series. S2 will be what? S2 will be A1 plus A2, then 5 plus 8 is equal to 13. Then S3 what will be? S3 will be 11, 8, 19 plus 5, 24. This way, if we used to know Sm, the summation of A up to n star, how will we can calculate? We have to calculate in this way. So we can take another page. We can use in this way. So first term will be A, second term must be A plus D, third term will be A plus 2D, and the nth term will be A plus n plus n minus 1 D. So here we have n number of A. This will be n A plus, and D and D are related in this way. D, if we take common, then we will have 1 plus 2 plus dot up to n minus 1. We have to know some summation of natural numbers, like a summation of natural numbers 1 plus 2 plus 3 plus dot up to n. It can be proved that it is equal to actually n into n plus 1 by 2. I'll prove it later. I'm not proving, I'm not just writing. So what we will get if we put this here, n a plus d into, here we will get n into n minus 1 by 2. So you can write it in another good way, that you will take n by 2 common, then it will be, if you take n by 2 common, then it will go to 2a plus n minus 1 d. And also you can write it the first term and last term, because here a and a plus n minus d is the first term and the addition of last term. There are many forms you can write. Summation of nth term up to nth term, any arithmetic progression. This is the formula. So keep it. Remember this formula. You can solve any problem. This formula. And if you like this video, like, share with your friends. And if you are not subscribed, subscribe. Thanks for watching.